Hello, today we're going to look at a problem that looks at doing hypothesis testing for a difference in means. So what we're going to do is we're going to be looking at measuring the effects of soft drink cans. So we're going to assume that a soft drink company is considering a style change to its current can, which has been the company's trademark for years. To determine whether or not this new style is popular with customers, the company runs a number of focus group sessions around the country. At each of these sessions, randomly selected consumers are allowed to examine the new and traditional styles, exchange ideas, and offer opinions. Then they fill out a survey with the following questions on a 1 to 7 scale, where 7 is the best. The attractiveness of the traditional can, the attractiveness of the new can, the likelihood they would buy the product with the traditional style can, and the likelihood they would buy the product with the new style can. And so we've got a couple of different questions that we are going to take a look at, and we want to say, what are these different questions? So we're going to look at how are they correlated. So we're going to go back and recreate a correlation matrix like we talked about earlier in the class. We are going to calculate out the difference for each customer on their attractiveness and would buy. We're going to create a histogram of those differences. We're going to ask, is there statistical evidence that the consumers find the new style can more attractive? And finally, we're going to put together, is there statistical evidence that consumers would be more likely to buy this drink in the new style can? And so let's go over here and let's take a look at our data. There we go. And so the first thing that we've got is we have headings here. So A, old, is the attractiveness of the old, and the attractiveness of the new. WBO, will buy old, will buy new. And we've set up these columns for AN minus AO. And so that difference would give us a positive value, would mean that the new can is more attractive. And WBN minus WBO, which means there is a more willingness to buy the new than there would be to the old. Now, before we even do anything, I'm just going to highlight all this stuff because we're going to go and we're going to use my range names. Gotta love range names. They're great. And especially if you remember, as we put together this correlation matrix, it's actually a lot easier to use range names anyway. So now what I've done is if I go, since I highlighted all those, if I go and highlight that column, you'll see that that pops up as AO. Now, just to note, we wouldn't have been able to name that like AO1 because that would be a cell designation in Excel. Just they won't have that. Okay, so the first thing that we're going to do is we're going to build our correlation matrix. So we're going to figure out all of our correlation coefficients. And so we're going to come over here, and how we're going to do that is we're going to go equals. And remember, our correl is our correlation coefficient equation. Now what I'm going to do is I'm going to do the arrays. Now I want to do the arrays based on AO and all that. Now I can't just sit here and go, okay, well, I want the correlation between AO and AO, because that should not work out because it gives me a value error, because it's looking for numbers and it goes AO is a letter, and that's a problem. So what we do is we use that command, and we're going to use that indirect command. And so the indirect command is going to take a reference string and put it in there, so a bunch of letters. And since we've already named something AO, when I go and say indirect K6, it's going to read that and go, okay, I'm going to look for the reference designation that's listed as K6. And actually, I want to use J7 because I wanted this one correlated to this, because I want it set up to positive values, preference towards the new style can. So we want to correlate, we typically correlate the first row, this first column to the second column, and then build it from there. Does it really matter? Well, no, because it'll just be reversed and flipped over, but I just want to be consistent with my own notes. And so as I drag this around, because I am going to drag, I want the row to be able to change. I do not want the column to be able to change on this one. because I want all these things to stay here because I don't want it to drag into the numbers there. So that indirect there, and I want to correlate that with AO. So I'm going to do it again. I'm going to use another indirect command, and I'm going to plunk out AO. Now, once again, since I'm going to be dragging this around, I want the rows to change, but I need to keep it on, sorry, I want the columns to change, but I need to keep it on row 6 because I don't want to drag it down here into the numbers. And so I'm going to put the $ in front of the 6. Okay, a correlation of 1, perfectly correlated. Well, AO should be perfectly correlated to AO. Now what I'm going to do is I'm going to hit Control-C because I want to keep these little green blocks in there. I'm going to highlight that entire thing, and I'm going to hit Control-V. And so basically what that does is that just copy and paste that equation everywhere. And once again, just double checking that my cells don't roll incorrectly, they don't index incorrectly, and it looks like everything works just the way I want it to. Always go and check those to make sure. And unfortunately, that got rid of my green highlights. I thought doing the copy and paste would keep that. I don't know why it didn't. Oh well, I'll just re-highlight those. So we're going to take those two cells, going to go home, and we'll highlight them in that little green. Okay, now I highlighted those two for a reason, because remember, positive values indicate a preference towards the new style of can. And so there is a strong positive correlation between AO and AN, which we show right here, and between will buy new and will buy old. So this so what does this do? Well, since there is strong positive correlation between those, it supports our belief that we should be using a paired sample, and that's what they did. The fact is, they had customers coming together and they gave their opinions on everything instead of having 4 different groups give their opinion on each different one to make them independent. So since there is that correlation between the old and the new, paired samples is probably the way to go. And so there's our correlation table, and it's looking pretty good. So part 2, they wanted to give us the differences for the ratings. So we're just going to go through here and would buy the attractiveness of the new minus the attractiveness of the old. Gives us a indication of what people think. Positive means that they prefer the new. Negative means that they prefer the old. And then would buy new minus would buy old. So positive value means that they'd buy the new one. Negative value means they'd buy the old one. And just right off the bat, that's kind of weird that they prefer the new can, but they'd rather buy the old one. So, but that's people for you. I'm just going to double click. I'm going to pull all that stuff down. Okay, and now what I want to do is I'm going to put together histograms of what is going on. And so I just want to get a histogram of this data here. We're going to do the first one, which is the new attractiveness is better than the old attractiveness. So we'll just insert in. We're going to go right to our histogram. We'll drop our histogram in. And we're going to make some changes to this one, obviously. So the first thing I want to do is always put in axis titles and units. And so, because people want to know what we're looking at. So we'll call this difference new minus old in attractiveness. Attractiveness rating. Okay. There's really no units for that. And over here, we'll just type in number of customers or frequency. I like using frequency, even though I have trouble spelling it. It means the same thing. I'm going to make this a little bit bigger. In fact, let's make it a lot bigger. Let's move it to its own chart. I do not like inserting charts into the Excel sheet, just because this is a lot easier to cut and paste. Although if you're using Tableau for your graphs, you don't really need this. And we got our title there. Okay, so the next thing is let's clean up these bins because these are kind of weird bins. So let's see what we can do. We'll go Format Axis, and we've got bin widths. Let's make that a nice even 1 and see what that looks like now. Okay, that looks a lot better. So we're looking at it. It's vaguely bell-shaped, and it's got a little bit skewed. If everything was going to be perfect 100% around the middle, we would expect these two to be a little bit more in there, but it's a little bit skewed towards the left. Because remember, we talked about the longer tail. There's a longer tail on the left. So a little bit skewed on the left means that it looks like people prefer the new can. Now, we can say it looks like they prefer, but is there statistical evidence? We're going to get to that. And we'll call this call this hist1 for our first histogram. So let's do the second one, which is going to be this will by new, will by old. And insert. I'll do the same thing in histogram. And let's move it to its own new sheet. And just also, oops, don't want to delete that. Always liked the having in its own sheet. So let's rename that hist2, and so people know what's going on. Let's get our labels and titles in. Histogram of new - old would by ratings. Add those axis titles in because we definitely need those. Frequency. Always hate it when you start typing and things get messed up. And then this would be difference in difference. Title at the old one, new - old. Would by ratings. Once again, these are weird bins, so let's go to Format Axis, bin width, make it an even 1. Okay, and so very similar to histogram 1, it is vaguely normal for the most part. Looks like it might be a little bit left skewed, so once again, if we're trying to show the management that, hey, we want to use this new one, this gives us a little bit of evidence that, hey, look, it looks like a little bit is shifted to the right. But once again, it's not statistical data. They're both fairly symmetrical, and there looks to be a little bit more in differences, so it looks like we've shifted a little bit to the right, so they're definitely left skewed. But once again, that's not statistical evidence. So let's go and let's look at our statistical evidence. And we'll do that in the next video.